Good afternoon. My name is Nicola Paciolla from Politecnico, Milan, in Italy, and I'm here to present my work on irrigation and precipitation hydrological consistency with a number of soil moisture satellite products. On the market, we have a large number of surface soil moisture products available from satellite, which have a number of differences in terms of spatial resolution, electromagnetic frequencies, or time frequency. What we wanted to find out was, are all these products physically consistent with the recorded rainfall? We tested our methodology over these two case studies in Italy, the Capitanata, which is the one in the south, and the Chiesa, which is the one in the north, irrigation consortia. So we chose irrigation consortia because that allowed us to have irrigation volumes information to include in our analysis. You can also see a list of our 10 products from satellite that we have used for the evaluation, with all the different characteristics that they have in terms of overpass time, acquisition system, range of the electromagnetic spectrum they refer to, effective revisit time, and spatial resolution. In order to answer to our original research question, we have developed the following methodology. For each SSM dataset, we've looked at the single estimates, measuring the difference in SSM from one estimate to the previous one, and the precipitation that has occurred in the meanwhile. And we have elaborated this decision tree that allows us to classify each and every SSM estimate according to this process. So for the green category is the A+ category or positive agreement category, in which we have physically consistent behaviors. So for example, an increase in soil moisture with the presence of precipitation, or a decrease in soil moisture with the absence of precipitation. On the opposite side, we have the red labeled category, so the A- or negative agreement category, in which we have the opposite behaviors. And we also have the blue category, or the IA+, which stands for irrigation-driven positive agreement category, in which we have the situation in which there is an increase in soil moisture with the absence of precipitation, but we know that for that day we have an irrigation practice taking place. So the HCI, or Hydrological Consistency Index, is the count, the sum of all the positive consistency cases, so the green and the blue ones, over the total amount of SSM estimates. One example of our methodology is for the Capitanata Irrigation Consortium. We can see in the lower panel the precipitation time series. In the yellow background we have the irrigation period, and in the blue background we have the non-irrigation period. The first and second panel are simply the two time series of the SSM estimates for SMOS descending and ESA CCI active. Each SSM estimate has been labeled to one of the three categories according to our methodology. The results tell us that in the non-irrigation period, the SMOS data register a similar amount of positive agreements as for negative agreements, while in the irrigation period, the number of negative agreements drops to 25% with the aid of the irrigation-driven positive consistencies. Another example application for our methodology is always for the Capitanata Irrigation Consortium, but for the Copernicus SSM dataset, which has the high resolution of 1 kilometer. We can see that the global averaged results are similar to those of the coarse resolution SMOS, but there is a spatial heterogeneity that mirrors the presence of irrigated fields. We have gathered in this table all the results of our methodology for all the test cases. We see that most results in the positive consistency area are concentrated between the 50% and the 70% thresholds, independently of the dataset we're looking at. We also see that non-irrigation performances look quite worse than irrigation ones. That could be because of the presence of irrigation information, but also because some unregistered irrigation volumes may have prompted us to misclassify non-irrigation days. One final remark is that L-band satellites provide slightly better performing data than C-band satellites, and that's coherent with the higher penetrating capacity of L-band satellite with respect to vegetation.